If you're confused on two proportion z-tests, here's a walkthrough of number 17 on page 520. Here's the problem copied over from the text, which you're more than capable of reading on your own. And here's the key information. We have one group of 284 students whose parents disapprove of smoking, and then we have another group of 41 students whose parents are lenient about smoking. So we'll start by defining our parameters. We'll say let P sub D represent the true proportion of students with parents that disapprove of smoking who will eventually become established smokers. Second parameter, PL will represent the true proportion of students with parents that are lenient about smoking who will eventually become established smokers. Anytime we do a two proportion z-test, the null hypothesis is always that there's no difference between these two groups. So in other words, the proportion of students in the first group who will become smokers is the same as the second group. The actual question asks us, is the parents' behavior influencing their smoking decisions? So is the fact that this one group have parents disapproving of smoking, is that making them less likely to smoke? So is this lower than the second one? Think about it like this. If we move this to the other side by adding that PL to the other side, we would end up with this equation. Okay, the disappointed parents group is less than the lenient parents group. Assumptions and conditions. Randomization. We're going to assume both samples of students were selected randomly and are representative of their respective populations. 284 is less than 10% of students with parents who disapprove of smoking, and 41 is less than 10% of students with parents who are lenient about smoking. Success fail, it gave us those numbers. There's at least 10 successes and failures in both of these groups. And lastly, since we have two samples, we need to state that the smoking rates of these two groups are independent of one another. We only need to check that condition when we have two samples. Name the method. This is a two proportion z-test. And in a two proportion z-test, to find the test statistic, we need to pool our data. Okay, so we use the pooled p-hat to find the standard error, and the reason for that is because of the null hypothesis. Remember, for every hypothesis test, we assume that the null hypothesis is true for the duration of the test. All of our decisions are based on the null hypothesis being true, and then finally when we get to the end and we see that that p-value is small, that's when we go back and we say we actually don't believe the null hypothesis, we believe the alternative. So if the null hypothesis is true, any difference that we see in these two groups is just the result of natural sampling variation. Okay, if we took larger samples, those two numbers would come together and they would eventually become the same proportion. So that being the case, if we just combined our two samples, it's the same thing essentially as just taking a larger sample, and larger samples are better. So we combine all of our smokers, divide it by our combined sample size, and we get a pooled p-hat of 0.2. Okay, that goes over top. So 0.2 times the q-hat, 0.8, goes over top each of our individual sample sizes, and we get 0.0668 for a standard error. And to find the test statistic, we need the actual proportions from each group. So among students with disappointed, or parents who are disappointed with smokers, 19% eventually smoked. Among students who had lenient parents, 0.268 smoked. Okay, is that difference large compared to the standard deviation? Okay, based on that null hypothesis value. Null hypothesis says that there actually is no difference. These two rates are the same. All right, so is this a statistically significant difference based on that standard error? We get a z-score of negative 1.17, which we'll use to find a p-value. So this is a left-tailed test. It's left-tailed because our alternative hypothesis said less than. If it said greater than, it would be right-tailed. If it said not equal to, it would be two-tailed. Normal CDF gives us a p-value of 0.1210. We'd fail to reject the null hypothesis since the p-value is too large. Our statement at the end, there's insufficient evidence to suggest that the parental attitude influences teenagers' decisions about smoking. That's just the text from the actual question. We could also word it like, there's insufficient evidence to suggest that students whose parents disapprove of smoking smoke at lower rates than students of parents who are lenient about smoking. One of the other parts in this question says interpret the p-value. If the null hypothesis is true, and there's no difference in the smoking rates between students with strict versus lenient parents, then the probability that the two samples would yield the observed difference or greater is 0.1210. So if there actually isn't a difference between the rate at which these students smoke, the probability that we would see that difference that we did in those two samples just from natural sampling variation is about 12%. That would happen 1 out of 8 times approximately. That's not unusual enough for us to say we reject the null hypothesis. Last thing it asks, if we made an error, what type of error did we make? We failed to reject the null hypothesis. There's only one type of error we can make when we fail to reject the null hypothesis. And when we fail to reject a null hypothesis that's false, that's a type 2 error.